perhaps you are using some of these libraries or APIs from Scala in your project already. Do you have any experience with what I'm gonna present? Is anybody out there who is using one of these three approaches to concurrency? Oh, good. Is this Future? Okay. Is this Akka? Okay. Is this Observable? Okay, good. Okay, good. So it seems that I should start with observables and then, you know, perhaps ditch other approaches. But then I can see that there are some people who didn't work with any of these three approaches to concurrency in Scala. So let me do this the proper way. So we start with this. Okay. Okie doke. Okay. Have it. So the idea is to have some slides first, and then, if time permits, we switch to REPL. You know, because we could all you know, jump into Scala REPL right away, but then I would probably miss some people who wouldn't understand anything I would type in Scala REPL. Especially that Scala REPL is pretty, you know, pretty flat. There is nothing but the command line. And I know that there are some people who are using Windows who are not accustomed to see command line very often. So just to, you know, to bear them in mind, you know, I'll stick to slides. Then I switch to Scala REPL, not to scare away you right away. Okay, so concurrency abstractions in Scala. Well, I need to lower my voice. Okay, so concurrency, nice topic. Okay, so concurrent future, Akka actors, and observables are these three main topics for today, all in Scala. So if you've been using RX Java or RX in .NET, the concepts are similar, but this is library suited for Scala development. So, you know, there are objects, there are, you know, some useful methods you can use without, you know, delving into details how you should be using it, because, you know, obvious stuff work in RX Scala too. Just once you absorb information about future, then we go to Akka, so you learn a little bit about actors, and then we go to observables, which should be quite easy to grasp because of these first topics. Okay, so my name is Jacek Laskowski, and I'm a full-time self-employed Scala developer, tech lead and advocate, Scala advocate. As some people may have heard yesterday, I decided to devote all my time in 2015 for Scala, and the reason is simple. I need to know if Scala is the language of my choice for years to come. So either it's now or never. And then I switch to another language if, you know, if there are, you know, market for this. For Scala there is market, so I'm paid well, so I can say, you know, Scala makes my life happy, definitely. In Poland. I'm not sure about your situation in Lviv, Kiev, or Ukraine, but Scala in Warsaw is flourishing. So you can find a couple of places for full-time Scala developer role in Warsaw. If you want to hear it, just approach me and ask me, you know, about it. So I'm also a Java champion, and that makes things a little bit harder, because, you know, I've just been nominated for this precious title, but at the same time I switched to Scala, and, you know, that's the reason I told you that it makes things harder, because, you know, I shouldn't say that Java is worse or better than Scala. I'm not gonna do this. So I just concentrate on Scala, and please don't ask me questions like, would you prefer doing it in Java? Or is Java better than Scala, or vice versa? No, I'm not going to answer this question because they depend on so many factors that the discussion would be irrelevant, I believe. There are lots of nicer topics we will cover right away. Okay, so yeah, I forgot this. Okay, so I'll do it soon. Okay, so concurrent future. It's a type constructor. So it's not a constructor in Scala. You can create new types out of using future type constructor, and that's the point of using future of t. It means that in the future you will receive some value of type t. Good? You are with me? Easy. Okay. And you will notice probably that I'll be referring to type system very often. And I didn't do this in Java that often, because Java didn't convince me to use type system that much. And to be honest, it was not that easy as it is in Scala. Even though Scala has more, expressive type system, the things that are available in Java weren't that easy as they are in Scala. Yeah, but this is not to say that Java is worse. Just this feature is much better suited to my understanding. It's more approachable to me. Okay, so concurrent future of t. It's a living object instance of something that's gonna be computed in the future. We don't know when, but it's gonna be of type t. So we can have future of t, meaning we can create a type. So it's a living object. So this living object will hold a value of this type t. So it can be an int, it can be, a string, it can be whatever type you can have in your hands. But it's a future. It's not available yet. So, and moreover, it might be a lengthy computation that may take a minute to compute or to finish, or a day. Yeah, it's possible, but it's gonna be available sometime in the future. That's the point of this future. Then it uses concurrent execution context, which you may have heard of or used in Java, because it's based on a very good concurrency abstraction library called Java Util Concurrency Execution. So this is just a wrapper of what you can find in Java. Very excellent concurrency library, abstraction too. So why should we be using future of t? It's because reasoning about anything concurrent is hard. So using future may give us some perception that we, imperatively compute this value. So there are some constructs in Scala, like for comprehension, that you can see line by line and think that might give you a false perception that it's being computed serially while it's computed in parallel. But then it's much easier to say, okay, when this value is going to be available, then this computation is going to be kicked in or processed further, and then the value is going to be computed, giving the 2 or more future values. That's the theory. Let's delve into some code. So we start with import. You know it, no matter what your Scala expertise is. So import, I assume that you've got some Java under your belt. So some expertise. So I import concurrent future. But don't get fooled that this future type or type constructor lives in concurrent package. No, it lives in scala.concurrent package. But since Java allows you to skip Scala, just to save you some keystrokes, I don't need to say import scala.concurrent future. That's it. Okay, I've got future in scope. Now the funny stuff. When I say that I am using object constructor, I'm using apply method under the covers. So I'm saying I wanna compute this one, which is a value already. So I could use, I know that it's gonna be computed right away because it's already computed. But then, assuming it would take some time to compute this one, I'm gonna show you that future from something gives you a future of this type. In this case, it's future of t. So this future 1 shows you that no, you are not going to execute it. Why? Because there is this execution context that needs to be implicitly available in scope. Why? Because beside this 1, there is implicit input parameters that are not needed if you've got this imported. So it's much easier to see this concept once you understand implicits. But for the moment, let's assume implicits let you hide some parameters, some input parameters, and are a very useful feature. Okay, so we got it. So we import concurrent future. Okay, we have it, and then we just import this implicit global because, as you may have noticed, the compiler told us to do it. So we don't need to, look or Google it, because compiler is nice and says, okay, do something like this, or just import this and be done with this. Okay, we just import it. So we import it, and then we create future of 1, completed value being 1. Okay, and we get promise, meaning this promise or this future is going to be completed when this promise is fulfilled. Easy? Easy. It's just a channel. So you can see future as a queue. So there is this input and output. And promise is the entrance, and the value that's going to be computed is an output. That's that easy. And it's available in Scala API. Okay, so you can also compute something, You can create something more expressive or more computation heavy. So I just future from, and there is this block that will give me a value of type int. We know it. These 3 lines are side effecting, and I'm using it just to show you that I'm sleeping of 1 second. I'm pretty sure that you are using time unit from Java. You are using it rather than thread sleep and then calculating how much it is to sleep 1 second. So this is from Java util concurrent time unit, and I'm saying, okay, I'm waiting 1 second, and then I print hello from thread name, just to show you that this is from another thread, and 1. Okay, so now the question is, how much time does it take to compute 1? Nope. Sorry? Nobody knows. Oh, we know it. So 1 second is not precise. And we are precise people. We know the proper answer. So 1 second it might not be the proper answer because of, so it's at least 1 sec. Yes, that's the proper answer. So 1 sec or more, and we don't know it exactly, but we know the lower bound. That's good too, right? It's much better than saying we don't know, because we do know. Okay, so on complete, what? We created 1f. 1f means that 1f is future, and there is this nice method called onComplete. It means that once this future is fulfilled or completed, this block is gonna be executed. So we are using Fluent interface, and we are using this nice looking methods like onComplete, and then once this onComplete is completed, executed, this println will get called. Okay, now my question to you, given the theory I gave you already, what's gonna happen when I execute this line? This expression. Sorry? Nothing. No. It's not an answer. It's just a type. Okay, in some... Okay, so the answer is, after 1 sec at least, it will print the value. Yes. So, and you're right that this value is printed out here, but that's my mistake to include this here, because, you know, I just hit it and this completed. Okay. So you're right, because, you know, while preparing these slides, I waited more than 1 sec and it executed. So once I hit it, enter, I'll get it. But I wouldn't have got it if I did this right away after declaring 1f, right? Okay, it might be a little bit messy what I'm doing right now, but I hope some people will benefit from this discussion. Okay, so questions? Yep. Implicit argument. Ah, okay. Yeah, this is the nice feature of Scala, where you print the only parameter that is being given to this function, because this block is just a function that's gonna be that's executed while this 1f is completed. Enough, because it's about Scala, and this is not a talk about Scala. Sorry. Yep. Okay, what would you like to see? The question is, let me repeat the question. The question is, what thread is this println? Oh, sorry. Oh my goodness. This println being executed. What's the thread? Current thread or another one? Another. Yeah, so yeah, it's another, but it depends on on this execution context, and, you know, this pool we created to execute this future. Let's see it in action soon. Okay, just keep that in mind. Okay, so we print and we done with it. Okay, future composition. That's very nice feature of future in Scala. So we can have and then is a method of partial function in Scala. So we can do like this: 1f and compose this function, this future, and say when this future is completed, we don't know when, let's execute this, and now we create something like a stream. So we pass it through this partial function. We print this value. We match upon. This is partial function, but this is also a pattern matching used here. So this is a syntactic sugar to create a partial function, and then we map this value. Beside printing this intermediate value, we multiply it by 10, and then for each value, we know there is one value, we print again. And what's the result? Momento. What's the result? Yes, 1 and 10, exactly. Easy? Easy. Because well, it's easy, but for some it might be harder because you don't know Scala. But once you master Scala, you will know that it doesn't depend much on future. You compose functions. Yep.
Could you please explain what is the return type of and then, precisely the expression inside the curly braces?
Okay. So in this case, it's gonna be try of 1 and unit and 1, because we wouldn't be able to map on the value if it was something different than, you know, it couldn't be unit, definitely. Unit is not composable. It's a procedure. We don't compose procedures. We hate procedures, right? You know what procedure is. You know the difference between procedure, method, and function. Okay, good. Okay, so you are with me. So what's the result? You know it? How much time does it take to compute this println? So execute this println. How much time? At least 1 sec. Yeah, exactly. Okay. And same for this for each. Yeah, same story. That's that easy, really. If it's not, ask Mikolai for a Scala workshop or course. He's gonna provide one for you. Okay, so handling failures in future. Well, we can say that this future is always failed, and failed future is when this computation threw an exception or throw exception. So, as you can see, I explicitly say that I'm throwing an exception, but we can also use division. So if we use divide by 0, we would get exception 2. So, but I'm explicit about what I'm doing in this block just for demo purposes. So I said, when this throw exception future fails, well, we know it fails, but then it computes failure. Then do this case, print a value or the value of this computation before, and then on complete will get executed. And guess what? This partial function is called again. Well, not again. This partial function is called, and we pattern match on these two subtypes of try, meaning failure and success. But I don't care about success. And this is a handy method. Three question marks, meaning I'm gonna throw an exception if anything matches this case. So it's very handy. So in this case, I know it's not gonna be the case because we know that this future is always a wrapper. It's a future of try, which is future of failure. Easy? Yeah, it should be easy. So we on complete and we pattern match and we there's a nice name for this from Clojure. So if someone uses Clojure, it should sound familiar. Meaning we destructure this object, this instance, into an X, which is of type throwable or exception, and then we print this exception. So what's the result? Yes, only future failed. Yes, but see, we compose many functions functional way, and look how easy it is to understand what's happening under the covers. Unless this future. Yep. Yes, it's gonna be executed. Yeah, why not? Yeah, good question. So the question is, what would happen if we added this case failure here? So we moved this line up 1 line, right? That was the question. So it would be executed because this is just a function. A function. Yeah. Anyway. So yeah. Yeah. Another question? Same. Good. Love same questions. Especially questions I know answers to. Good. So, any questions about futures before we jump into actors in Akka? Yep. Nope. Okay. Sort of. Okay. Let's leave it for another session. Okay. So, but it's a good question. But you are forcing me to think imperatively. I hate it. So, for comprehension is for people who love object orientation in an imperative way. Well, object orientation is imperative approach. But we are functional programmers, right? Shorter. Okay. Well, I've got function composition, so I can have one-liners and compose my application as a one-liner of compose of. Yes, but leave it for. Okay. Opinion? Always functional. Always functional. Always. And if I'm not functional, the only reason is that I'm Java champion and I'm trying to transform my mind after 20 years of working in Java into functional programming language. After a little bit of closure, I switched to Scala only because pursue my understanding of how it is to program functionally. But hey, Scala is also object-oriented. And then I've got object orientation and functional approaches, paradigms, and it's not easy to pick the proper one because I'm partially functional, partially object-oriented. But I love challenges, and Scala gives me challenges all the way, along the way. Okay, actors. Nice feature of Scala, which are using futures too. Okay, so actor model, a little bit. I was born at the time actor model was created. So it was in 70s, the past century. So in 73, one guy created actor model. So we waited, almost over 40 years to learn about actor model. At least that was the case for me. So what is actor model? Actor model is just to perceive your world as a scene with actors that do something, just like we are listening, just like you listen to my talk. We are all actors, and we can behave differently depending on what I'm saying, right? But then we can just reason about our behavior in a controlled way using this actor model. Actor model is just a model, and we are trying to model reality. So this is a mathematical model, and for concurrency, for concurrent computations, that treats objects as actors. So whenever you see object, you see an actor, and vice versa. Who worked with Smalltalk? Who developed? Yeah. So one person. Okay, I'm not gonna, Łukasz, ask you about your experience in Smalltalk, but my question was towards, in Smalltalk, you would notice that you are sending messages to your objects. That's what object orientation is all about, right? So actors are like objects. So that's natural to us, Java/Scala developers, to understand this computation model. But then we need to think about it, that all is happening concurrently. All. So we don't know if we fire off a message to an actor, to an object, when and where, which thread this message is gonna be processed on. So, but we've got some primitives so we can control it. Okay, so that was easy. Okay, so actor model in few lines. So in actor model, you see messages and actors. And actor, in response to a message, can. What an actor can do with a message or upon receiving a message? Make local decisions, meaning it can compute something. I don't care what, because I'm not concerned with what's being computed. I'm concerned with what thread this computation is executed on. Then this actor that received this message can create another actor or more actors and can become a supervisor of these actors. And think about it. If an actor can create other actors and these actors can create more actors, we can see this interaction as a big tree, and that's the point of using Akka in your architectures. We can see this tree, and if a node and subtree fails, we don't bother about it because Akka will handle it depending on strategy we employ to handle failures. That's the point of using Akka. Not to have concurrency, because we have it with futures, but to have this supervision. That's the point. Okay, so an actor can pass a message, this message that it received to another actors, or create another message and send this message, create a new message and send it to other actors. Okay, questions? Yep.
When we need somehow manage the sequence of computation. For example,
Yes, computations.
We need to launch a couple of instances in EC2 and provision them with some kind of software. And
Yes.
in the end, we need to send notification to other servers that okay, it's already done, so we can start.
Yes, exactly.
So, is there any way to manage it with Akka?
Yes, there is. You can pipe to another actor. So you can chain actors, and because you know that you can create new actor. So I'm creating another actor. This another actor will create yet another actors. So we have a chain, and we can pass messages through them. And then the last actor can pipe this response, its computation result, to the origin actor via actor ref. That's that easy. Well, let's think about it. If you want to call to my wife, I would not like it, but let's assume that you want to call to my wife, how would you do that? You would ask me about a number. Oh, no. Don't do this. But you could. You could try.
I will try to find maybe in your Facebook.
Yeah. Good idea. So you would ask an actor called Facebook for information about me and my wife. And Facebook would ask me if it can provide you this information. Yes, it could. These are actors. These are all actors. You an actor, me an actor, Facebook an actor, and then we could do this. Why? I'm gonna show an example of this. You could wait for an answer, but it's wasting resources.
My question was about do we have...
Okay, I'm gonna show an example. Wait a moment, okay?
No problem.
And I'm gonna answer this question in a moment. So I'll keep that in mind. So actors are objects, naturally. We can send messages to actors. Actors can change behaviors, so they can become something different. You know, they can grow up a little bit and respond to other messages like, give me a phone number of your wife. You wouldn't be able to answer this question when you were, 10 years old or 5. But then after some time, you became able to answer such questions, right? Such messages. So before you got married, you would respond with some unknown message or an unknown message exception. Then after 20, you would respond, I don't give it the response to you. Okay. So think about how to escalate failure in case of Akka. That's something that Akka differentiates itself from other actor model implementations. So Akka offers not only actor model, but also this tree-like structure of actors that communicate between each other. Questions? Okay, good. And moreover, keep that in mind. Let it crash. We don't care about failures. We know that if a failure occurs, Akka will handle it somehow. Well, it's always like this. Somehow. It's just an abstraction, right? Yep.
Can you comment a situation when child actors flood the manager with messages?
Flood a supervisor?
With managers. There are many child actors, and they're always trying
It's
to
too complicated. It's
access.
too complicated to answer easily, and others might not couldn't benefit from the answer. So I'd say let's restrain from this question, and let's get back to this after this talk. Okay, so actors in Akka. So you can create actors, and actor is a container for state. Think about it. Actor is a mutable object. You can mutate it without thinking about any functional composition or being pure because functions should be pure. No, actors are not pure as far as what they hold is concerned. Meaning, they always accumulate state. That's exactly for this use case. So we accumulate, and do something after some time passes. So we have some state, we can change behavior, and all communication is done using mailboxes. So every actor has a mailbox, so you do not send messages directly to an actor. You are using actor refs, and Akka handles passing these messages to appropriate instance of this actor. Why? Because we could have a cluster of same actors and handle the load using 10 or 100 actors behaving same, right? Okay, and we are using actor reference to talk to actors. Okay, let's have some fun with code, and I'm missing some time. I'll need to speed up a little bit. So I'm creating this. This skeleton gives me a way to create an actor. So an actor is just a class that extends actor and offers an implementation of receive method. That's it. And I gave you this hint about the type of returning value. This is a unit, and acceptable value, the acceptable type is any. So meaning we do not care about types in Akka yet. They are working on typed actors. So we just pattern match on received messages and do something. But this is just a skeleton, so I use this triple question marks. Okay, actor messages. We are in Scala, so we are using. So we use case object or case classes for messages very often. It's just a pattern to create an object, a companion object in Scala to our actor class, because then this actor class can use and others can use this too, knowing that these are messages for our actor.
Does Akka support nested case classes when sending messages through the network?
Jo, da.
So did they fix it? Because as far as I remember,
They fix it. Let's stick to this answer that they fix it, unless I misunderstood your question. Okay, so actor-based application skeleton. You need an application to fire off, to instantiate actors and then use them properly, right? So you need an actor system. So you need application server, sort of. So if you know Java EE, you needed application server for a container for your EJBs, for your servlets, for other stuff that was managed. And actors are managed too by something very heavy called actor system. So create instances of actor system sparingly, meaning it may take time and memory to create more actor system. If you don't need them, more than one, just don't create them. Don't treat them as lightweight objects. They are not. But once you create it, you've got a system so your actors can be created via this factory method, actor of, and we create this actor using this name, using this input parameters, using, well, in this case, there are no input parameters to this actor, but hey, we don't care about it, it's hidden, and we send a message initialized to this actor. This message is of any type acceptable for this actor. So this is a way to send a message using this ref. The type of this is actor ref, and we send a message to someone in this actor system that can handle, that's pointed by this ref. That's it. After a while, we await termination, and after a while, system is shut down in a proper way. Questions? It's all about actors in Akka, pretty much. Well, there is more, but there's always more. But that's the basics of actors. 5 minutes, good. Wow. So, I wouldn't be me if I wouldn't mention futures in Akka, because that was the reason why I introduced futures, because they are used in actor, and this is the answer to your question. If you need an answer from Facebook that asks about an answer from me, and you don't care how many actors are involved, you just use this pattern ask, and you wait for response from Facebook, and guess what type is of this response. So when you execute this, there is this return value. I don't use it, sorry. Future of this response. Future of number of my wife. Phone number. Okay, and then if I receive it, I just, await. I can do anything I want, but since I'm in actor demo, I just await termination and terminate. That's it. So this is the answer to your question. Ask pattern. And this ask pattern uses future. Good. Questions? Nope. There should be no question right now because I've got only 3 minutes. Okay, good. So, observables. Nice abstraction, but works quite differently because the way it was created. And you know what? You know that any theory has co-theory, meaning there is a dual theory to this theory created. You know it? That's what Scala taught me. You always ask question why. Why and why and why. And you don't stop it. Why? Because you need to know more. So if you've got a theory, you say, you may ask, is there a co-theory that might be as useful as this theory you just created? And that's the answer to one of the many questions you may have had, meaning, is there something dual to iterators? So instead of asking implicitly or explicitly on next, if iterator on next returns true, I'm gonna do this something. So I'm pulling, right? Observables give me a model to be pushed, to be told that something is available. That's the observable. That's it. I finished. Well, not really, but if we run out of time, that's it. So instead of asking if there is in this collection a new element, I'm gonna need this and do something. No, we just subscribe to a stream. It's not a stream, but kind of, and receive this element. And think about it. If you move mouse pointer, are you generating events? Yes. Are these events an array, like data structure? Or can they compose, or can they create something that you may perceive as an array of events? Yes. It's a stream of positions of your cursor. And now, instead of asking if mouse moved, you say, if mouse moves, I'm gonna do something with it. And that's it. Okay, so you subscribe to a series of events. So observable, it's just a pattern to do it. So observable object represents a push-based collection. So it's still collection. It might not be finished. It might be a stream, unbounded stream, but it's still a collection, right? So, and there is this observer and observable interfaces. Yeah, something like this. Yeah, but they are wrong connotations. So please restrain yourself from using these. Just call them observables. Okay, so trait. This nice minus here. So it's contravariant. Love this space. I'm not there yet, but so I couldn't understand it fully. But I know that makes a difference in presentation to use this contravariant word. So, okay, so observer is contravariant on T type, and it's a mechanism for receiving events. And there are only 3 methods you need to implement. Just on completed, you know what it is for. On error, you know what it is for. And on next, and I'm pretty sure that you know what it is for. Who doesn't know what these 3 methods are for? On next value. Yes, So it's not. You shouldn't bother about it. It's observable that moves, and you watches the move. Observer watches. Yeah. Okay. So uncompleted is called, or on error, and the stream is completed. On next, every element is generated. Then on next is called. Okay. Observable is covariant on T, implements reactive pattern, and you can easily create your own too, just to move through the sequence and generate these events. Construct new observable. So this observable is to create observables that emits events. And this is an example. Easy? Should be. Look at this. Observable, I create an observable that emits elements from 0 to 10, a sequence. We know that this is a sequence, but they could also be, mouse movements, mouse positions. And then I say, I need an observer of this stream of values. So I subscribe using subscribe method. And that's it. That's all you need. Momento. Let's talk about it afterwards, after the talk. Sorry. What was your question? Yeah, so that's all, guys. And if you've got any questions, just please ask them right now. Yes. That's easy because this is our implementation. This is us to implement it. We know when uncompleted was called. How do you know it? You don't know it. Yeah, but mouse position are, yes, that's correct. Until you shut down the system. So it's bounded. All is bounded. Unless it isn't. Okay, other questions? Yep, please. Yes, you can. Just after you subscribe, you get a handle, and you can call unsubscribe and be done with it. Anytime. From any handler. Yeah. Yeah, it's that easy. Yeah, really. Yep. A difference in your life to explain it. Yes, I can. A feeling of it. After this talk, please. Okay, sorry. Yep. You can combine concurrent operations because because observable can be executed on another thread. It depends on where this on next is being called. Yes, actors and observables are pretty similar, and they implement something which is called reactive manifesto, which is implemented by reactive. It's like question: do I need juice, orange juice or apple juice? You prefer orange or apple juice? Yeah, it's like this. Yeah, it's just another approach. Yep, another question? A last one. Yes, please.
My question is about observables. Is it easy to introduce memory linkages in your program with that program?
Rather not. It's not that easy because this is a stream and you don't know when and if you were called previously because there is no state. There is all functions are pure, so no trace of if I were executed previously. So it's pretty hard to but then, Yeah. Yes. Yeah, it's cheap. Yes, that's cheap. Yeah. Okay. Thank you guys and thanks for your questions and